So one of the organizations that works towards to ignite the curiosity in the young minds is SSCRT, and I would like to call Mahesh, the R&D head of SSCRT, to give us a brief about SSCRT and Gen Space.
Okay, thank you, Garvin. So to start with, so most of you here know who we are, what we do, what really SSCRT is into. But again, just a brief of why do we do this? That is the most important question, right? So when we talk about space science, the first question is, why space science? Of all the problems humans have, like global warming, climate things, hunger, poverty, water stuff, why really space science? Why people spend that much money, and why you emphasize people learning space science? So that is the most important question. And all our initiatives is towards answering that. Now, if we humans truly understand who we are, where do we are, how significant we are with respect to the vastness of space, then the way humans might perceive the world would be different, right? So humans might start to learn that this is our only planet, and there is much beyond that, and again, this is the only planet. So yeah, that is the whole point of why we do this. And we do this through a lot of our initiatives. For example, we make sure we have space science as one of... Yeah. So we have space science as one of the subjects in all the schools. So as far as I know, the only place where we learn about space science is one of the chapters in our subject called science. Even now that is true, right? So it's better if there is a subject called space science starting from the schools, where the young generation would truly understand who they are. Because we humans already have this natural instinct called curiosity, right? So if we trigger that from the young generation itself, that really works out. So these are some of the programs that we have been doing for a very long time. And the best part about these programs is the students itself. The excitement that they get when they learn new things, and the curiosity, and most importantly, the questions they come up with. That is the best thing. Right? So we don't just stop in schools alone. We also take these programs to the universities, undergrad students. So we have designed a lot of workshops which will help the students in engineering and other bachelor's degree to learn things more in a practical way, through hands-on experience. So this is one of the recent workshops which we did in a few colleges. The students learn how to build and launch rockets. How do you exactly build and design a CANSAT? So yeah, this is that. And another best thing that happened to SSCRT was we got featured in one of United Nations Office for Outer Space of the stories. That was the best part. Because when we do such things and if we get appreciation from places like these, it really gives you this moral boost, you know, to keep us pushing in whatever we are doing. So yeah, that is one of the best things. Now, there are two globals and two names wherever you see, SSCRT and Gen Space. And I had a lot of you question, what is Gen Space? Because you are very familiar with SSCRT, right? So we started with non-for-profit things. We were teaching a lot of students space science, but at some point we also had to take commercial projects, right? We had to expand what we are doing. So we pushed all the education stuff into a new company called Gen Space, and we retained all the research things with SSCRT. So that is why you see SSCRT and Gen Space. So SSCRT is the parent company, and Gen Space is something which came out of SSCRT to concentrate on the education part of the whole organization. Yeah. So these are the few numbers and things which we have achieved so far. We have done more than 250 plus programs and 50K plus. I think that number is old. We have touched more students than that through all the programs, and we have been to, or our programs have been to 50 plus countries. So yeah. Now, as I told you, so we have created this curriculum, the space science subject itself, starting from grade 1 all the way till grade 12, and we are also doing it for engineering students as well, so that they'll get much more better space science curriculum in their schools. Next. Yeah, so whenever people think of space science, the first thing that people get in their head is astronomy, stars, planets, galaxies, or black holes. Black holes, most of the students think black holes when they talk about space science. And there are also rockets, there are also satellites and stuff. Actually, there are a lot of other things which comes under space science. So whenever we teach students, we make sure that we cover all those aspects which comes under space science. For example, you have space medicine, you have space food, you have agriculture that can be done in space, and you have space laws, entrepreneurship, and space industries. So these are the things which people fail to understand, or so we include all these things in our curriculum. Thanks. So this is another best thing happened. This was our long time goal. We wanted to set up labs in schools. Now, as far as I know, we only have science labs, math labs, and a few schools have language labs. But again, space science is not exactly a subject, so they don't have labs. We wanted to set up space science labs in almost all the schools in India, possibly in global as well. That is a future goal. And this was the first lab which we set up in one of the schools called Arthur Public School in Trichy. And another exciting news. So ISRO wanted to make their contents available for the students. So they are getting into education as well. They wanted to give it to the students whatever they do to inspire the younger generations. So with that, we actually became the official content partner to ISRO. So ISRO have come up with a few programs called Eureka, and also there are more programs in queue. And the contents that they will be developing for the students, we are the official partner, so we'll be developing those contents. Again, we are really proud for that as well. And this is one of the recent things actually. So we won this Elevate 21 grant through Startup Karnataka, again, which really helps for us to reach more students and expand our programs what do we do throughout India. So with that, I would really like to conclude here. So again, what we do here is for a single goal, right? So when people say space is one of the final frontiers, well, space is the final frontier. So if people truly understand that, things might change. We might really start to learn something else. So, Garvin?
Thank you, Mahesh, for introducing us all to the SSCRD and GenX space. Well, as far as I can remember, I was about 11, 12 years old when my curiosity got ignited. I was traveling in the night and there was a full moon, and I just got stuck to that full moon. Like, how I just started asking questions to myself, like, how is that thing floating out there, right? And if I cannot see the sun when it is fully bright, how can I see the moon when it is fully bright? And why is it following me, right? So all these questions just got stuck, and only if I had some space science education back then in my school when my curiosity got ignited. Well, speaking of the moon, today also happens to be the International Moon Day. Does someone knows why do we celebrate the International Moon Day? Someone knows? Yeah?
Because today was the day when Neil Armstrong first set foot on the moon.
Exactly. So, on 16 July 1969, Neil Armstrong, Buzz Aldrin, and do we know the third name? Yeah. Michael Collins. Okay. So, these three very brave people stepped foot on a very strange machine that had an explosive equivalent of 400 tons of TNT. Do you know what that machine was? The Saturn V rocket, right? So they set foot upon the Saturn V rocket, and after about 109 hours of travel, Neil Armstrong became the first person to set foot on an alien world. A place that was not Earth, right? It was a totally different celestial object. So to enlighten us more on this topic, about the moon, we have Dr. Kumar Krishen with us. Sir?
We'll play the video.
Introduction.
We have a small introduction video of Dr. Kumar Krishen, which will be there.
Turn it. You have it.
It just has a little lag. The video will be. Well, till the video is playing, do you know who was the second person to set foot on the moon? Yes, sir. Buzz Aldrin. And there are also some comic answers to that, Neil Armstrong was only the second person to set the second foot on the moon. But yeah, Buzz Aldrin. Okay, so Buzz Aldrin actually joined Neil Armstrong after about 19 minutes of Neil Armstrong being on the moon. So they collected about 21.5 kilograms of lunar soil when they were on the moon. So they collected that lunar soil and they brought that soil back to the earth for various experiments. And they, when they landed on the earth, when they came back to the, what was the date?
It's there.
Today?
We may not have too much time.
7 days after that, right? So it was 24th of July 1969 when those three very brave people came back to the earth while they landed on the Pacific Ocean. Okay. So they landed on a capsule on the Pacific Ocean. But let's start with the introduction.
I'm going to begin by introducing astronaut Terry Wilcott, who will be presenting the NASA Exceptional Service Medal to Dr. Krishen. Terry Wilcott came to NASA's astronaut program in 1996 after serving as a
May I suggest that I stop bit over?
4 space shuttle years, so I'm very excited to be a part of this prestigious presentation. I'm going to begin by introducing astronaut Terry Wilcott, who will receive NASA Exceptional Service Medal to Dr. Krishen. He flew 4 space shuttle came to NASA's astronaut program as a pilot and 2 after serving as a Marine joining NASA's safety program after the Columbia mishap. He now works at NASA headquarters located in Washington, D.C., where he serves as NASA's Chief of Safety and Mission Assurance. So I'd like to welcome Terry Wilcott.
Thank you, Vanessa. It's a privilege for me as a NASA executive to, attend an awards ceremony, be part of it, especially considering the exemplary service of Dr. Krishen. As an astronaut, it's a special honor and privilege to be able to thank someone that contributed mightily to the success of our human spaceflight programs. People often ask me still how I ever had the nerve to get inside a shuttle and launch into space. And I tell them,
With moon. And you will see a little bit of that I will bring in the talk. And even some people call it Chandamama. Huh? And we associate beauty with moon, right? Chand jaisi dikhti hai. Huh? So there is a lot of romance that Bharatvarsha has had with moon, being so near us, being so observant. My talk is very long. I'm going to go very quick on some slides. Some slides I might spend a little more time. So I'm going to talk about space exploration, and then I'm going to bring in the question of moon. So what will we talk about? We'll talk about space exploration and utilization in the next few decades, because that's the trend of the world. That's where the entire set of countries, at least I know 4 or 5 of them, and you do too, Russia, China, United States, India, Japan, are out there and they want to conquer the space. And why? I will say a little bit about that why. Next thing, what are the challenges? This talk will be empty without giving you a little taste that going in space, doing things in space, on the planetary surfaces like Moon and Mars, is not child's play. It's a very serious thing, and it is the most challenging, I know, environment to be in. Finally, Chandraman, the moon. So towering genius disdains the beaten path. It seeks regions here unexplored. When I reached America in January, early part of January of 1965, I saw a magazine. On the page of the magazine there was President Abraham Lincoln with this quote. I cut that page and framed it. It stayed with me all my life. Remember, the second sentence says it. It is what? Genius mind seeks regions here to unexplored. We cannot sit idle on this earth. We have too much energy. You're seeing little kids at home. You have to be very careful. My daughters were giving, I have 3 daughters, such a tough time. They will go to bathroom, they will open the doors of the cabinets, they will examine knives. So you have to be careful. Exploration is in our DNA. We are born with it. We explore anything, we explore everything. So now, this is my thinking. I think the greatest challenge of humanity ever, before our time, at the present time, and in all the future to come, is finding, understanding time, space, energy, matter, and life. Just think as you go out of this presentation, after I am done, what is time? When did it start? When will it stop? Can we do anything without time? No. So the question is, who made time? And after that came in my mind, space, energy, matter, life. And we have a lot of these things termed as dark matter, dark energy, because we don't know much about it. I have several talks I give on different things. But you see, at least in the next 2-3 decades, I say next 50 years, there will be so much activity. Young ones will be so fascinated with exploring the moon, the Mars, the Earth. Earth needs to be explored. And NASA, ISRO, many other organizations are exploring Earth, because there are a lot of secrets. This is the only planet that we know at least has life. So, it's the most probably complicated planet ever. Maybe in the whole universe, at least we know in the solar system. And then you have these black holes, the beautiful things that have right now, and ever after Chandrasekhar talked about the, have grabbed the attention of the whole human race. What will happen in the next 50 years? We will be exploring and putting assets in the Lagrangian points. These points are very fascinating because you put the assets in them, They are not stationary, they are moving points. Everything is moving in this universe. Can you think of one thing that is constant in this universe? I'll tell you in a second. There is one constant. Everything else is changing in this universe, and there are many other universes. So you have these Lagrangian points, also called cislunar points, and you will see a lot of nations using them, putting assets there, assembling things there, and using them as transportation nodes. So now, next few years of space exploration, solar system and entire space exploration. I'm going to go real fast on this, but you will see telescopes. You are already seeing James Webb telescope. You are seeing all kinds of, Chandra. You are seeing Hubble and many other telescopes. Observations are key. We are going to spend a lot of time on observatories out there and out here on the Earth, storing, assembling, and stationing human labs. We'll talk a little bit more about that. Moon and Mars mission technology development, communication infrastructure is not so easy because, we are now spoiled a little bit. We have a real good communication infrastructure around the Earth with the satellites and with the GPS and so on and so forth. Now, we'll have to have communication infrastructure for the entire set of, planets such as Moon, Mars, and asteroids. They all have to be linked in a way that we have a communication infrastructure. GPS will be needed on Mars, for example, on Moon, etc., etc. So Space Force came about in the United States in Trump administration, and it's opening up doors to space in a very different way. You may not like it, you may like it, but the fact is space is going to be used by no other than the military of many nations, right? So that itself is a different twist. We'll talk about Moon and little bit more, but Mars is going to be explored. There will be a human mission to Mars. I don't know how many astronauts, maybe 3, maybe 4. It's the most challenging thing. NASA spent in 1990 about 4 years, maybe even slightly in that time period under George H. Bush. We spent about 4 years scoping a mission to Mars, and it was incredibly complex. And I can talk about that for hours and hours. But the most conclusion was it's extremely expensive. Even at that time, even with the way we were kind of, I think, fudging the factors, still it came out to be 600 billion in about 1990. That would be trillions of money now. So human mission to Mars will happen. Of course, we'll talk about the Moon and what will happen to Moon. There's another twist that has happened very recently. I was interviewed by this magazine, Lifeware. This Alison Matthews interviewed me on behalf of space sector. But why do I bring this up? The traditional companies that have been involved in space exploration will be there. Companies like Boeing, Lockheed, SpaceX, ISRO. ISRO is not a company, but I'm saying all these NASA, they will be there. But what fascinating, Microsoft, SpaceX, Google, Amazon, Microsoft, Facebook, I could never think that they would be so interested in space. You're seeing what? Venturing into satellite communications, looking in terabits of data. Particularly if you take, for example, Google, they are memorizing data for the Earth, they will memorize data for the Moon, Mars, the space, and they will make a big fortune out of processing this data in space, satellites, storing it there For some reason, I don't know what the reasons are, but that's where the trend is. There will be thousands of satellites in low Earth orbit, in geostationary orbit, in many other places. Even could be these Lagrangian points that we talked about. So, big tech has money. They have trillions of dollars. That itself will explode the space sector, right? It's non-traditional things. I'm not going to go too much in. Innovation will be the key. These new companies which had very little to do with space, now they have a lot to do. They want satellites, they want data processing, they want to communicate the data, they want data on demand, they want to sort out that, etc. But you are seeing trillions of dollars of companies are coming in. And when I was asked by Allison, what do you think about this? I said, it's the greatest thing that can happen to this space exploration, because these guys will bring innovations, they will bring money. Both are needed. So now, little bit about moon, and then we'll talk a lot. The thing about moon is, everybody talks about, hey, there is some water on the moon, but it's locked on the two polar regions, right? So, don't get me wrong, and I don't want to probably go on record, but this kind of things NASA did a long time before. We surveyed the moon with radars, etc., but ISRO has also done the same thing. But how, especially I want to challenge the little ones here, it's not so easy to get that water. See, when we say something, I want to give you the complexity. That water is a lot more stronger than even stainless steel, because it has been there in extremely low temperature for billions of years. So it's not so easy to harvest, right? It's logged in. You have to heat it up to 600 degrees centigrade or more. By that time you get other gases involved, and it's a mess. It's not so simple to do little things like that, getting water out of where. When people say there is water, we think it's like a well, like we have here on the earth, right? Giant line, we will go and get it. No. Now, what has fascinated me in this, this is Dr. Herschel Schmidt, astronaut. He was a geologist. He became a senator from New Mexico. Great personality. But look at what happened to his spacesuit. It got a lot of dust. So I got interested in this dust. I'll come back to dust. Dust is going to be a big problem. I recently wrote an equation for the dust storms on Mars, and I sent it to AIAA to for their review and comments. But I said this. Please remember this. I said, sometime in the future, the dust on the Mars will simply put a mission to dust. That might happen. It's not a simple problem. Especially on the Mars, there's a little bit of environment, so this dust goes in the environment, and then it falls on your solar panels, for example, or any structure, and it causes detrimental effects, right? And you're seeing over here, he had a little tear, so there's a complex nature of this dust. It's not so simple. Again, I can give a talk on dust alone for much of the time. Then there is this galactic cosmic rays and high energy particles that come from Sun and many other places in the universe. Now, what do you do about that? That's a big challenge. I'm talking about a little bit, giving you a hint. That going in space, doing things on planetary surfaces is not so simple. This itself can kill a mission. It can kill the electronics. It can affect the humans even though you are shielded by stainless steel. So in NASA, we're looking at many possibilities, especially when you're doing extended stay, like we'll be doing on the moon. We'll be staying there for a few months, for example. A little bit of a habitat on the moon. Of course, going to Mars and back will take 2.5 to 3 years. And that would be detrimental. So this has been one of the tallest goals, and slowly NASA is solving it. So I will not go too much deep in it. Now, Aerospace America gave an article in November of 2022. The article said, thriving in space. What are some of the things? Communications, food production is a big problem. How do you produce food on moon or Mars or inside a closed thing like you have space station? Why is it important? Because two challenges must be addressed. One is called recycling of resources. If you take air, water, etc., you have to recycle. You can't, over here I can go and call somebody and say, get me a bottle of water. Of course, air is free here. What do you do on the moon? What do you do on the Mars? What do you do when you are in International Space Station? So the greatest thing you can do is recycle. And that technology comes on the Earth. We'll talk a little bit more about that. So food production is going to be great if we address the most tough problem of growing food in an environment and in the soil where it's impossible to grow. So manufacturing, how do you manufacture something on the moon or Mars? Over here we have difficulty. If I told you tomorrow to manufacture coal or anything, it doesn't matter, rocks, or process something, it's a very difficult thing. Mining, water production, need for on demand. I need something now. How do you do that? Mining metals, mining, for example, something that is in the soil that is useful to make something there. So transportation is a big issue. And again, I'm saying thriving in space. This is what you will see. People spending a lot of time on these things. Communication, food, transportation. So, for me, a lot of people think you must have seen in a movie, growing things is so easy, right? Ta-da! You get crops. No, you don't. You don't get crops so easily. The soil is very different. Mars dirt, high in pH, so you have to do about that. About 2% Mars surface has calcium perchlorate, that's a toxic substance. And over here we are spoiled. We don't realize it. Earth is very different. You can just throw a seed, you can get a plant, right? It's not quite as easy as it looks in the Martians. That's the bottom line. And so simple. I'll give you, people have simulated soils from Mars, for example, and they are not able, unless they process that soil infinitely more, and then they are able to do something. So I'm not going too deep. You can see how I am skipping a lot of detail, but giving you a top view of some of the things that are on my mind. So, as a general comment, before we go to the moon, I feel like a lot of these nations, one of the things that we'll be concerned about, have left things. All the things that we did, I say America, 12 astronauts were on the moon, 6 missions. Whatever they took, most of it stayed there. They brought back some rocks, right? Stayed where? So China sends something, India sends a package down there, right? It stays there. So we are polluting, and this is what we did to the earth, right? Polluted the air, polluted the water, polluted the land. What are we doing for the moon? What are we doing for the Mars? Are we getting these things back? They are going to be there, they are rotting, they are doing their things. I think this is not acceptable behavior on the part of humans, right? particularly in this nation, in Bharatvarsha, we have always thought of moon as a holy place, right? And you keep bombarding it with this trash. It doesn't look like a good human behavior. So I'm saying there will be a lot of people spending some money and getting this back, like we are doing for the low Earth orbit. There is so much debris floating, people were throwing things out, trash, and it caused such a humongous problem ever since. Now, coming back to the great thing called moon, right? I'll give you a little glimpse on the moon, and I will be doing it on a very high level. The first thing I will say, what I got by studying moon is these kind of things. Moon is the only natural satellite and fifth largest moon in the solar system. Moon's presence helps stabilize our planet's wobble and moderate our climate. Now, you have to study. This is something that is almost summarized from a book, right? How does it do it? Not so simple. Moon's distance from the Earth is 240,000 miles. The moon has very thin atmosphere called exosphere. And of course, moon has been bombarded with asteroids and comets, and that's how that bombardment has resulted in craters and complete moon dust, right? So, Earth's moon is the only place beyond Earth where humans have set foot. 6 times. There will be more. We'll see in a second. China is going to be there very soon. So, moon causes tides, creating a rhythm on the Earth. So, moon is not sitting there, Chandamama, for nothing. It's somewhere moon and earth are tied together. It's like 2 sisters or 2 brothers, right? There is interaction going on. So the moon was likely formed after a Mars-sized body collided with Earth. Now for the children here, not for adults, I have a question that you could be thinking for the next few months, maybe even years. That is this. As far as I know, moon is going away from us about a couple of centimeters a year. The 2 questions are, why is it doing that? And second question is, what will happen after 1 billion years? Or a few billion years? So these are things to think about. They're called brain teasers. So, one of the things that I'm fascinated, and I think India should get a lot of credit for, is the research that was reported sometimes 7,000 years back, 6,000 years back. That is really the measure of time. Years, I'm telling you, in this country, the smallest time was defined thousands of years ago. It's called Truti. Truti is 1/10 of a nanosecond. 1 divided by 1 and 10 zeros. How did few thousand years ago humans in India come with the concept of Truti? And the concept of Truti is such that it was defined as an atom of time. Like you have atom of hydrogen, oxygen, right? Atom of time is Truti, 1 divided by 1. How did they do that? And then there's a methodical, step-by-step calendar of events. And I'm not going through it. If you want to see my paper, I will send you. And it's not mine. I just borrowed it from the ancient scriptures. But what do you think is the highest, the longest time defined in Bharatvarsha? It's called the life of Brahma. And I was at Virginia Tech NASA sent me for 3 years. I had a lot of time. I was teaching, I was doing research. I had a real nice corner office, huge, that belonged to a vice president. He went to another building. He said, Kumar, you can hire me. Because I was camping. So I was having fun, I was being innovative. What I did during that time, I took the Indian calendar, which is based on the motion of moon around the earth, and tried to relate it to the solar calendar, which is based on motion of earth around the sun. I translated these two and came out with the life of Brahma, which in this Bharatvarsha is considered the Mahapralaya, when the entire universe will annihilate. Before that there will be pralayas. There is going to be a predicted pralaya, according to India, within the next 3 billion years. And can you believe, when I was presenting this theory of time to some of the people at Rice University and many other, NASA also has predicted now there will be that pralaya, because sun is expanding. Okay, sun is also losing its energy. It's not going to be constant. So in about 3 years, it will engulf the earth. There's no possibility of having life on earth. That's one of the pralayas, early pralayas coming up. But the longest pralaya, when I calculated it, I was shocked. It came out to be 3141519, etc., etc., trillion years of life. You calculate it, I'll send you. It's not my calendar. Now, what is so fascinating about 3141519? Can you believe it? I was so fascinated. I gave it as, on my second page, I had written a storybook called Why Me. On second page, I said, this is the place, said by an Indian. It's a storybook. This is the place where the lowest time was defined and the longest time. And we know that time is circular. It never stops, it never ends, it never begins. Can you believe? God. The rest of the things I can't say. I can't say about space, energy, matter, life, etc. But I can tell you, now, this is how I kept asking myself, how did in India they measure time? It's very simple. You can see why. You can see. The size of the illuminated portion of moon made them to think hard and, what do you say, define the interval. Change defines time. Now earlier I said there is one thing that's not changing. And if you can prove other than that thing, something is not changing, I'll be so thankful to you. Everything is changing. But there's one thing I think that's constant. That is Brahma. Some beliefs call it Allah. Some call it Rab. Some call it God, right? Doesn't matter the name. That one thing, the most super thing, is the only thing I can think of is not changing. Nothing else stays constant. Look at me. It's shocking. As a small boy, I looked so beautiful. I had so much energy. Look where I am now. It's hilarious. Thank God I still have my teeth. I can hear good. I think my brain is working good. So, but these things are what change. I'm not kidding you. So, last thing I want to share with you is my tango dance with moon. Are you ready? Okay, good. So it began as a child. I was born in Kashmir, and place where I was born was probably about 9,000 feet above sea level. Absolutely no pollution. Zero. You could see the moon like, wow, it's here. It's next to me. So, my thing, I would never stop talking, so my mom used to say, please give me a break. Just shut up. But I was afraid of my dad. But even then I would ask both of them, please tell me what's on that thing called moon, huh, Chanda? My mom, are you ready? What my mom told me? There is Bhagwanji. Brahma is there. And there is a pool. That pool has milk. Milk? Yes. Then she would say, in that milk, it's boiling milk. And then you have all kinds of dry fruits in it. Coconut, almonds, blah blah, raisins. By that time, my mouth is totally water. Almost the water is coming out. Then she would say, if you take a sip, you will be having nirvana, samadhi. That was my mom. Then I would go to my dad, who was pretty good, highly educated at that time with a matriculation he had done from Norman High School, the only high school in Kashmir. But anyway, I would go to my dad, he would say, sorry, I can't tell you, I don't know. That's my first time. Then, when I reached Calcutta University, I was in Calcutta University for 4.5 years in the Institute of Radio Physics and Electronics. I did some, 2 degrees there, Bachelor, B.Tech and M.Tech. After that, I did research. I was going to get a PhD before then I decided to go to America, but I'm not going. Under 2 people, Dr. J.W.R. Griffiths from Birmingham University, England, was on sabbatical for a couple of years. So what were we doing? Suddenly, he came up with the concept that we can send a signal from Calcutta to moon and it will be received in New Delhi. Wow, it's a great thing, using moon as a passive reflector. We were using satellites at that time as a passive reflector. We were using ionosphere as a reflector, etc. But it turned out to be a very complex thing. I was asked by him to do the transmitter. I did the transmitter, but actually he left before that, and therefore I had to also leave Astronaut. So that's my second tango with the moon. Moon relay communication system. I learned a lot. I learned how the signal, electromagnetic wave signal at X-band, 3 centimeter wavelength, will interact with the moon and then get reflected. We had to do that. This is, we are talking about 1964, 63, 64, before I left for America. So when I reached America, the first task I was given by Dr. W.W. Capsule, the head of the Department of Electrical Engineering. He said, hey, we got a project from NASA. And the project says, what is the material on the moon? Because when these astronauts such as Neil Armstrong, Buzz Aldrin will go on the moon, will they experience a quicksand? They go down and never come up. What is the material and what's the compaction of that material? But we hadn't gone to moon in 1965, right? So I had to take this. What I did is, I'm going to be very brief. I constructed this system, microwave system. I went on the roof of Seton Hall, big roof. Why? Because I made a target like moon, and round thing, circular plate, and I would put different materials on this target. I would even rotate that. I had a motor from behind. Why did I go on the roof? Because I didn't want to get any other reflection. If I would go in the room, I would get reflection from the walls and all that, not necessarily only from the target. So I went on the room. Now, are you ready, kids, if I told you some humor? So I am doing this in extreme cold, you can see. But I had this blood circulating in me. I wanted to get some answer, right? In a minute I will tell you how the answer comes. So I am doing this, and the head of the experiment station or something we call it was going down there, and he looked up there. He called my head of the department under whom I was working. He said, this fellow will be frozen very soon. You better bring him down from the roof, otherwise we will have a frozen icicle rather than this guy, right? So I came down, and I was given one of the largest rooms, the envy of all the professors. I was a student, right? But then I had to put anchored material around, do you see? So that I don't get the reflection. When that material was not there, if somebody was walking in the hallway 2-3 rooms away, I would see a little blurb on my observing station. So you see, that was my moon with different materials. So how is this related to moon? Quickly, very quickly. I came up with the concept, let me not measure the amount of energy that comes back. We had Goldstone. From Goldstone there were two scientists, last names Evans and Pettengill. They were sending Goldstone, we have 75-meter dishes. They were sending X-band signals to the moon, getting them back. And they had the data. So that was the real data from the moon. I didn't have. I had the simulation data. But they luckily were not looking at something I started to look at. They were looking at the amount of energy that comes back and then trying to relate it to the material properties of the moon. What did I do? I related it to what is known as depolarization. See, if you have, I'm talking to kids now, if you have a radio, you put that antenna of the radio at some position, you will get the best voice. That is the position where the electric vector is parallel to the antenna. So I was studying how that electric vector will change in the laboratory with the different material. And then I wrote to them, and they were kind enough to send me all the data that I wanted, and I extrapolated from my measurements into their actual measurements and predicted the material on the moon. So here is my major advisor, another professor. This is me. I look like a professor, but the newspaper people came, and so it was a blast because it was like astronaut drivers benefit from K-State. I was in the news. I was very happy about what I had done, and so now let me talk about closing comments. China is making big strides right now as we speak. They are going to make a big international space station. They are also working quite hard on the mission to moon. And they will explore. Look, a moon base is very likely to host the first humans living on the surface of this sphere other than planet Earth. And this is what they are saying openly in the literature. And this is given here for you. So, moon will be explored. And at this point, I will also tell you my tango. When we were doing this Apollo 17, we were told by the Congress and the Senate, no, that's enough. We went 6 times, we failed 1 time, that's enough. We spent a lot of money, we spent a lot of time, okay? It's good, we learned a lot, that's it. So, my boss asked me, can you give some explanation why we should continue to do lunar exploration? So, I came up with couple of thoughts and wrote them down, typed and gave it. First thought I think of it, moon has this vacuum. So if you have an experiment that requires no particles, you can make it on the moon, you can make a mile, 2 miles, 3 miles. Over here on the earth, if you have a lab like Indian Science Institute or somewhere else, making a vacuum is a big thing. Large Hadron Collider is like 7 miles and it eats your lunch to vacuum something and make sure that there are no particles inside. So first thing I told him, look, we can make perfect vacuum on the moon. Okay? And we can do an experiment that might require 300 kilometers. There is no chance on the earth we can do those kind of experiments where we can accelerate particles and do any kind of magical things that require vacuum, right? Second thing I told him, that we can have permanent observatories. See, James Webb telescope right now is somewhere. Is it reachable? Can we service it? We serviced Hubble, it costed us a lot, Orman Lab. So James Webb telescope got hit with some comet or something, some particle in the last couple of days, and you are seeing the damage. But on the moon, if we leave the assets on the moon, observation assets, we can change them, we can bring new technology to them, and they are permanently watching what? Outer space, they are going to watch also Earth, etc. etc. So that was my point, that you have a permanent place to be there. But of course, being on the moon and living there for some time has its own benefits. What are they? If you can live on the moon and use in situ resources, we call it in situ utilization, in situ resource utilization. And you also do this recycling of resources, right? You have achieved something great. Why? The earth is changing. I didn't show you those slides. It will become a long presentation. Earth is changing. What was cold will become hot. Where there was snow, there will be no snow. Where there was no snow, there will be snow. Things are going to be very different. Hurricanes, you are seeing floods, are changing the tapestry of the earth. So my point is, the things that we learn by being on the moon in an environment that is so harsh cannot allow us to go outside unless we are fully, dressed with spacesuit, etc. You can see how that technology will transform here on the earth. You could go to a cold place like the Himalayas and perhaps make habitats. You could go to a desert, make a habitat. You could go to a waterlogged place. It's all the way. So anyway, there is a space race going on, and China will be one of the things that will prompt India. This is my prediction, not to sit idle. India is already kind of way behind China. Right? China already has sent astronauts in low Earth orbit, especially a lady. And China is training a lady to go to the moon. That will be kind of like their point, here, a lady came to moon. So far only men came to moon. So helium-3 also is being talked about quite a bit. You can harvest helium-3, which is important for fusion, fusion to create lots of energy. So Japan, this article just came out, okay? Japan says, I can transport humans from moon to Mars, don't worry, from Earth. Here's your train, I can do it. So we have, especially all the children, we have lots of thoughts and ideas. We have to sort out these thoughts and ideas. And sometimes, that's why engineering comes in. Sometimes even if you have a capable idea, you may not be able to implement it because the cost may be so big. One example, SpaceX. Who is in charge of SpaceX? Elon Musk. Says we can colonize Mars. And I say, Dr. Kumar Krishen says, why do we have to do that? Why? We can learn a lot by being on the Mars, by having a mission to Mars. And I can tell you, any technology that we develop all the way from Mercury, Gemini, to all the way to International Space Station, we use that technology here on Earth. I can prove to you. You can see laptops, you can see phone, you can see any device in a hospital, in transportation sector. We never left anything untouched. We brought it back to the Earth. So I am for space exploration, for the benefit of humanity, for raising the standard of humanity. More than 12% of world population is living in poverty. No clothing sometimes, no food, no way to stay, nowhere to stay, etc. But India is going to be even more needing high-tech innovations. Why? In 2024, India's population will be more than China. It will be the most populated place, probably most densely populated place. So India has to wake up. We have to wake up to the fact that new innovations are needed to grow more needed things. And I say, what you learn from space exploration will be so great, incredible. So I think I'm coming to the end. Let me see. Oh no, I have 5 more minutes of material. Can I share that with you? So now I was looking at the moon from the Earth, right? One example I will give you how it can revolutionize things on the Earth. Suddenly when the Congress of the United States and the Senate said, hey, NASA, stop it. You can do something on the Earth. So suddenly NASA started an Earth observation program. We are talking now 1968-69. Started an Earth observation program. And I was given the responsibility for microwave sensing of the Earth. Incredible thing. So what we did is we did a methodical. We first understood the reflectance and emittance of different things. A tree, grass, this, that, soil. You know, we wanted to get a library of what is known as signatures in different parts of what we call spectrum. All the way from radio waves to all the way to high waves like the visible part, you know, red, violet, etc., etc. So now, going back, that remote sensing of the moon, by the way, that remote sensing was also done through the orbital sensing, you know, from the orbit of the moon. That came back, and soil moisture is one of the projects I was involved in. So we looked at how to send the soil moisture with different sensors. I was going too deep in it. And now that's being used. There is a soil moisture satellite that's being used for crop forecasting. Some of the things I did as I learned how to do the moon remote sensing are these. Let me give you an example. Development microwave techniques for remote sensing of hurricanes and earth resources. Hurricanes are called typhoons here. Now we have a clear understanding. We can tell you the velocity, we can tell you the path of the hurricane, etc. It's all based on satellites, and ISRO has earth observing satellites that can give you this kind of thing. I did a first study of the oil spill. there was a Chevron oil spill in Louisiana, off the coast of Louisiana. So I tracked it at night and day, and it became a very good thing for oil companies. You know why? Kids listen. It's shocking. I did it because it was coming to the shore and people wanted to see what kind of resources they need to contain it, right? To deal with it. But it turns out that if you go away from the shore, sometimes oil comes up because it's lighter. So when it is lighter, wherever it comes, you got a gold mine, right? That means you can explore offshore. That and that is monitoring of soil moisture from space, I already talked. And then I even came out with, NASA told me, okay, design, and Kalpana Chawla was involved with me. She was my friend, etc. will not go there. And I took her advice and help, and we were doing some research also on robotic vision methodology. How do we give vision to a robot? Basically, I started from where? Looking at the moon, and look where it ended up. So that's an example. What are you thinking? Right? Thank you.
Thank you so much, sir, for enlightening us with your wisdom. That was actually a very unique way to know about the surface of this moon. And for sure, the exploration of the moon, we will go there because the moon is actually the doorway to forever. So we are open now for questions. So all the participants that are here and all the people that are watching us online. So if they have any questions, we are open.
Good evening, sir. I'm Bharati, and I want to ask a question. You mentioned that time is like a circle and never started, never ended. But we're all believing that the universe began from the Big Bang, and that time must have also begun from that place. So, how is that possible? If time started then?
Okay. One simple thing. If I gave you zero time, can you have a Big Bang? I told you I will give you zero, zilch. For Big Bang, you might need 10 to the power minus 50 seconds. I don't care. But if I gave you zero time, think, you cannot have a Big Bang. If you cannot have a Big Bang, you cannot have a universe. So, Dr. Ting, so Nobel laureate, he came to NASA Johnson Space Center. He was talking to a few people, including myself. At the end, he's a particle physicist. He does practical things. Right now, he has on the International Space Station, he has an experiment to catch what's known as anti-gravity particles. Okay? Dr. Ting, you can do little looking into the Google to see his experiment is right now going on. I asked him this question at the end. I said, in Asia, we have this concept that time, and I had done that paper before that because I had come back from Virginia Tech. So I said, time is ever constant. It's there. It's not going away. So he looked at me, and the answer was very, very, very nice. He said, that's why I do experimental physics. That was essentially what he said in a very nice way. Kumar, I do experimental physics. I avoid these particles, etc. So think. Without time, nothing is possible. Not even the Big Bang. So I say to myself, I convince myself, like the people living in Persia several thousand years ago, time is there all the time. Time is there all the time. You can quote me on it. Did I answer your question?
Thank you so much, sir. Do we have any other questions?
Good evening, sir. And as you said, if we can grow plants and crops on Mars and Moon, it will be a lot easier because we don't have to carry our food and all to Mars. And is it possible to grow soil and crops, plants and crops on Mars? And because it's rusting, many people say it's rusting, and it's red, it has iron oxide, and it's not suitable for growth of plants. So is that true? And is it possible?
It will be possible. We will have to take certain things from the earth. So we will use the regolith as such. We may have to process and get rid of some toxic material from it. So you can imagine, at least you have the basic regolith, right? You don't have to take it from here. But you can imagine if we take few kilograms of needed material to kind of process this Mars regolith, Mars soil, process it, and then we can grow the plants. So my hope is that we will take some need. If we find those type of substances or compounds or whatever they are on the Mars, great. Most likely we won't. But if we, as we speak, there are a lot of people working on this simulated Mars soil. They're mixing things with it, etc. And they're trying to find out what's the minimum things that we have. And Mars soil may not be homogeneous. It may be different in different places. So we have to be intelligent. We will use Mars soil in a place where minimum processing has to be done, right? So if we are successful that way, I think we can grow plants on Mars. Did I answer your question? So,
can you do some chemical reactions or something to get the fertile soil on Mars?
to get
Fertile soil on Mars?
that will be done. But apart from that, you may still need some things from there. Yes, there will be some reactions done, but apart from that, there will be probably some need. I'm guessing it because when I read that paper, it's a recent paper, they had analyzed, you need pH this much, you need this. See, over here we also have biological, what do we see? Biological, those insects, right? In the earth. And they are marvelous. And who knows, we may have to transport some of them into Mars. Maybe not, maybe. But I think we can do it. We have the basic soil. Once we mix it and all that, then it will become, what do you call it? Self-sustaining system, hopefully.
Good evening, so I'm Akshay. I'm in my final year of engineering currently. So today's lecture, I was very thankful you told us the parallelity in religion and also in space technology. With time being, a circle, the cycle of life, etc. That actually showed a new aspect. Now coming to my question, sir, if suppose we had to design an exoskeleton, since China is already supporting human life there, for humans, Mars exoskeleton is already being designed, but if we had to do it for Moon, what would you think would be the prime requirements that has to be taken care of?
For a simulated human being?
Yes, sir. If we have to put it, and simulated suit kind of thing which will support human being with the China drawing a lab out there. Suppose humans had to live on moon and you had a suit to be designed for, what are some functionalities that you think we should be taking care of while designing?
We'll have to, we have done a lot already, right? First of all, the suit will not produce air, will not produce water, right? But if we have to use the suit for a longer period of time, we'll have to have a system to collect what's coming out of us. What is coming out of us? Perspiration, something coming like urine, and I'm not going to say what comes out from the back, right? So if you're going to think about a marvelous suit, it may not look like a suit. It may look like a triangle. It may look like a, what do you call, a rectangle or whatever. You will have to think, if you have to put this human being for a longer period of time, you have to provide that essential way that the person is biologically satisfied, right? Now once you do that, you can see if you don't take care of things properly, there will be germs, there will be infections, there can be a lot of things. So I'm thinking if I have to design a suit for a longer period of time, I will have to process some things. And it's not complicated. We already know how to process urine. And in the International Space Station we are doing it. In fact, if I understand it right, the astronauts don't have any objection to even use that. But we don't know how to process what is coming from behind. So we'll have to do those things. That's what the challenge is. The rest of the challenge, we know how to keep the person cool with cool air, things like that. We'll have to depend a lot on the solar power. So it's not like, how do I say, we'll have to have mobility, right? Mobility, dexterity, flexibility in the suit. Now mobility will be provided by tapping on the solar power. So if you can tap very efficiently the outside suit with solar power, you will have enough power to process whatever you want to process. So I don't know how to answer it. It's a very good question, but those are the challenges. Now we have a suit that has certain how do I say, flexibility, mobility, etc. But after a few hours, what do you do with the astronaut? I have to tell you this, I'm sorry. But what happened early on, I think it was early mission, I heard it from Dr. Chris Kraft. Okay? So he said, once we sent the astronaut, I think that astronaut had to go further than low Earth orbit. But when that astronaut reached low Earth orbit, he called back, he said, I can't hold it anymore. I have to go. I have to pass urine. Biological. He made us laugh. He said, because he was the flight controller, So he said, he told him, go ahead. And he said, suddenly, the temperature in the entire module, the lunar module, came down. So there is a lot to be done in terms of making a suit, because essentially you are making a habitat that can be worn by the astronaut for a longer period of time. Did I answer your question?
Yes.
Those are the challenges. And last not least is also the what do you call, cosmic rays and particle impacts. We'll have to shield from that also. Because you said for an hour or two like we did in Apollo, it may not be that detrimental. But if you are out there for hours and hours and doing certain things, you need to shield this astronaut from the harmful cosmic radiation and charged particles.
Good evening, sir. First of all, very energetic talk. I've listened to very energetic talk, so thank you so much for being here and giving the talk. So the question is for all the small kids. My son is 12-year-old and I think 14-year-olds and all that. They must be in 7th grade, 6th grade or 8th grade and all. So what should be their trajectory if they are having a passion towards the space science and all that? So what exactly they should do in the next 5 years or 10 years to be, for example, maybe something in the space station or maybe something, for the India, for the globe wise. So what is the message for the small kids, and like how they pursue it to the next level? Is my question.
Wonderful, wonderful question. Excellent question. I say, basically, be strong in your studies. For instance, you can think about all these things, but how does it help you when you have to solve a mathematical problem? So you have to realize that knowing fundamental things like physics, chemistry, biology, mathematics, all these subjects, plus sometimes even knowing other things such as costing of things, planning of things, how do you become a scientist? How do you get interested in space? What does it mean? Nothing at the end of the day if you are not deeply knowledgeable about things, right? So to that extent, the coming into space is going to be so easy. It's like Kalpana Chawla was a PhD in fluid dynamics and all that, right? So you understand space much better when you have a strong educational background. I would say a little more on this side of technical background. I'm not undermining people who are going to study commerce, economics and all those things. Those also we need to have nibbles of that. But fundamentally, understanding of the universe, how things function, how things you make, like rockets and things like that, right? You have to have that. Now you cannot skip. You cannot say, okay, I'm not going to worry about this. I'm going to worry about making something grow in the Mars soil. No, that should be a part of your educational process. Okay? My children did incredible projects, even in 8th, 9th, 10th, 11th grade, 12th grade, published papers, you can see them. Published papers. But the thing is, that was a part of their educational system. They were learning about biology, for example, or physics, or chemistry, etc. So my advice, stay on top of education. And I'll say this, think about studies as, what's the best sweet you like? You? Kaju ki? Think when you are studying that I'm eating kaju katli. What about you? That also? Rasmalai. That's what one of the schools said. And you? Gulab jamun. And you? Huh? Rasgulla. Wow. You got a variety of things. I'm not joking you. When you're studying, think about that. Something sweet. I am getting it. I understand Newton's laws. I understand how a rocket works, etc., etc. Your stamina will increase. You will be hungry. You will think of knowledge as something sweet, something you want to have, right? Not something better, something you want to avoid. This is how I was, seriously. From all I know, from second grade, third grade, I used to love to read books, and whatever little I have achieved is because at that age, man, if I could multiply 3 number, for example, 6, 7, 8 by 6, 7, 8, wow, I was feeling some great achievement. And as I grew, if I could do Bernoulli's theorem or Bessel function or what do we call, all kinds of different things that I did myself. So all I'm saying is, be happy. Taste it in the brain that you are getting something great, and that something great will graduate you into space. What was your favorite? I didn't ask you. Rasgulla. Wow, all of these honestly are my favorites. But I used to tell kids here in India, Gajar ka halwa, socho. Seriously, I was telling them, studies, think of Gajar ka halwa ka. Suddenly one girl told me, after almost a year, I'm not joking here, she said, but I like, what did you say? No, no. Rasmalai. You said Rasmalai, I think. She said, but I like Rasmalai. I said, okay. You think of Rasmalai. It was shocking to me because she said, but I don't like Gajar ka halwa. I like Rasmalai. Okay? Did I answer that question? Step by step. You can't do skip. You gotta go grade by grade. You gotta master the thing. But if you are capable and you are reading 3rd grade or 4th grade, right? Read 1 grade ahead. That's what I did. Why did I do that? I was reading almost 2 grades because my elder brother was 2 steps ahead of me. I was stealing his books, reading them. So I had a step ahead. So get that step ahead. Rise early, sleep early if you have to. That's it. And don't forget, Saint, I think it's Kabir, what you want to do today, do it now. Now. What you want to do tomorrow, do it
Today.
Thank you so much, sir. I think we have time for a few more questions. So,
yeah, it was a great speech. My question was, what should be India's next move?
What should
What should be India's next move about space?
What should be India's
Next move, I guess.
next move in space?
About space.
India has a tough road ahead. I'll be honest with you. The tough road is because if you don't do anything, let's say for 2 minutes, because, see, for instance, I will go on a big discussion, but I will cut it off. I'm not quite sure if we should be spending a whole lot of energy and effort in exploring deep space. Yes, some of it is needed, but not necessarily all the time. If you ask me, yes, explore solar system more because we're here, right? But going back to India, India is in a paradoxical, what I call a paradox. If you don't do anything, your neighbor is going to be way ahead, and they are already pushing their boundary down. I read in the newspaper that India is saying, please move behind a little bit. During the time of Nehru, they defined a line called McMahon Line, China. They just came en masse, and I'll never forget, I am going to paraphrase Nehru. हमारे सिपाही बहादुरी से पीछे हटे, बहादुरी से पीछे। I was in tears. क्या बोलूं? So India is in that time frame. Space gives any nation incredible technology, and Space Force that United States has created gives an incredible edge for any nation. So now the problem that I see with India is it needs resources. India hasn't sent a human in space. India most likely doesn't even have the infrastructure to train these astronauts. I hear from, not necessarily from reliable sources, maybe that India is getting astronauts trained from where? Russia. And India's Rakesh Sharma, who launched him? Yes. So now the question is, India will have to start making things. It's a big challenge. It's not a small challenge. But going back, the next step is make. Don't buy. Stop that. Try to stop that. Long time back, we were buying even the blade for shaving. It was coming from England. We were buying tea. Tea was being, if I understood right, taken from Darjeeling to process in England and then would come back as a real packet. So the challenge to India is start making things, and that making things will come into space sector. That's what China did. 50, 60 years ago, they started with fundamentally making electronic parts, then they started making mechanical parts, bigger parts. Now, China has the largest antenna in the world and a couple of other largest things. But what does Emirates have? The largest building in the world, right? But China is looking into high tech. They are saying that they will build, their space station will be much larger, and you're seeing how they are dreaming of being on the Mars, a moon, a mission to Mars, etc. So, long answer, winded answer, short is make things yourself. Don't start importing everything and then launching it. Did I answer your question?
Thank you so much, sir. We have some questions online. Champa Ashok asked that if we dig through the moon, what are the most important resources that we can get?
Some people say helium-3. Helium-3 is something great, right? And some people are also saying there could be some minerals. We haven't seen that from the lunar rocks that came to NASA Johnson Space Center. We haven't seen any magical elements. But I would say the most important thing is helium-3, and I hope and pray that there is plenty of it, because if you spend so much resource, you better get something, right? And that would be good for fusion, and we don't have much on the Earth, but if moon has plenty of it, so be it.
Thank you, sir. The last question is from Atroid. He asks that if we cannot see the sun at night, why can we see the moon at night?
Well, that's a question he must answer himself. That's a question that he should answer himself. And I can give only hint, right? Nothing is stationary. Things are moving. Hello. So what happens? When things are moving, they are not only moving, they are rotating, they are wobbling as they are moving, right? So the, what do you call, the orbit is also weird shaped, right? So all these things come in terms of where is sun, where is moon, and where is earth. Simple. The thing about what I learned by being, my mind is always in the universe. I'm not joking, I'm not making it up. That's why I joined NASA, because I wanted to understand this thing. So I keep myself busy thinking about it. Nothing is stationary. Everything is changing. I told you the only changeless thing is Brahma, known as Bhagwan, Bhagavati, whatever you call it, Allah, whatever name you give, God, Rab, and many other names. That could be probably constant everywhere, anytime, any space. The rest of the things are changing. And once they are changing, can you imagine? The earth is moving around the sun. Sun is moving around something else. The whole solar system is moving in Milky Way. The whole Milky Way is moving around Andromeda. They say that Andromeda and Milky Way are going to bang up with each other in the next couple of billion years, right? Everything is kind of stormy, changing, kind of randomly going about, but at times regularly going. Randomly going about because things are happening, like this 2 centimeter. Something is happening. It could be also happening to the earth because the energy of the sun could be also wobbling it somewhat, right? So things are happening that we don't know. And we have these 2 things I call that sustain the universe. I call those 2 things gravitational field, and the other one I call kinetic field. If you don't move, you have difficulty. If you don't have gravity, you have difficulty. There could be other things that come into play, like energy, etc. Energy that we don't see. But at least these 2 things are well placed in the universe and make it to churn and make it to sustain. So the question to him is, try to answer yourself.
Thank you so much, sir, for enlightening us with your wisdom.
So in closing, I want to thank SSERD, and especially I was invited by Nikita Shetty. Did I pronounce your name correctly? And she is a gem. She, some of my colleagues call her awesome. I used to call her super. And then my colleague told me, Kumar, she is awesome. So you are awesome, and your company is doing real good education, trying to further the R&D. Everything starts with a small step. You never know where you could end up. But anyway, you have made the impact. SSERD has made the impact. And I thank you for inviting me, giving this chance for me to express myself. Thank you.
Now I would like to call our co-founder, Sridhar, to present a small token of gratitude to our chief guest.
Thank you so much, sir, for spending your time.
Thank you so much. Thank you. Come closer.
Thank you so much for joining us.
Anybody else wants to take a picture?
We will take a picture in another 2 minutes. You can sit down, sir.
Okay.
Thank you very much. work, this work.
Oh, can I also give you two a present? Hold on. I will be back in a second.
Yeah. Okay. Since he's
Okay, I have a present for you. I wrote a book because when I went to America in 1965, there was strange impression of India. Seriously, they thought India is a poor country, and the best thing about India they could think about is, and something comes out. What is it called? Snake charmer. ये था impression. So, long story short, I did a few things, my family did a few things. And one of the things I did is I wrote a storybook about 14 stories, essentially telling them we have a great culture, we have done a lot of thinking, we have great values, and we have a lot of love for humanity. And this is all it is.
Thank you very much, sir.
You are welcome.
Just, I'll finish, wrap it up in 2 minutes.
Sure.
This
Take
is
your
what
time.
we will just finish it off because people are waiting here. I know few of you have questions yet, which you will be very happy to answer, but I just want to wrap it up because we have a lot of audience also waiting online, and I just want to send them off because it's due. So you all heard from Dr. Kumar sir, telling about what's going to be the future already, and I had it already, so I'll just run through the pictures. So this is the plant that China planned to grow on the moon, using the moon soil, and this is how they grew. It was really nice, but after a week they died. But this is how it looks, and this are the pictures of NASA growing the plants of on the moon soil again. Like this is regolith of the moon. This is recently done, and this soil was taken 50 years back, right? So this soil was taken from moon and brought back to Earth 50 years back. But this experiment, conducting the experiment, happened very recently, and this is what the pictures were released. 1 gram of soil of the moon was taken, and they ran the simulation, and they were growing the plants. This is like the beginning for everything that we heard from Dr. Kumar. This is something that came out of India. Okay, can anyone take a guess what is this? Sorry? No. You're very close though, but some component. But yeah. Sorry? Yes, it's a brick. It's called as moon brick again. So if you look at this, this is made up of the lunar soil with several other components, and urea is one of the liquid used to make this brick. So it's basically, if you plan to go in the future on the moon and want to construct the habitat, instead of taking the bricks, the way we construct the house here, I always tell the students, do you think we can construct a house like this with doors and windows and the bricks and cement, water? No, right? You got to think of something else, and that thought has already started, and these are the results that we've already got. And this research was done in India in IISc along with ISRO, right? So you make the brick out of the lunar soil, so which could be used. This is very tiny. We've got the results, but this could be applied for a bigger run, So, there are so many other things also to be done, but I think these are like the starting things to look for the moon. And along with this, the Artemis mission is coming up. Like, can you imagine, like this soil was brought back like 50 years ago, and now we are planning to go back. So I'm guessing more research and more results and more scientific knowledge, and I just see the world getting to know more and more about the science part of the moon, and in fact our life, our future, the future generation going to live on moon and Mars. That's what I see. Very good, and in fact in India also things are starting off even with ISRO's Gaganyaan project. Like sir was telling, you know, we were so dependent on others, and he said it's so good that we have to start building it by ourselves. And I think that point is something that even India is focusing on and have started building the Gaganyaan project. And I see we getting more and more opportunities over here for Indians for sure, and then why not for others as well. We know how, like, you know, the technology, whatever ISRO comes with, they keep it pretty much open for everyone, and it is something for so supportive for everyone, right? So I see things are coming up really well with not just India, with NASA doing these experiments, China planning to, you know, I see everyone like going forward. That's like the development, the progress towards the space. I mean, moon is just the beginning, because that's the closest celestial body we have. That's what I personally think. Just to go on to say what we have been doing and what support we are looking for from your end is, SSCRD being a not-for-profit organization, we are looking to support students in education, in particularly space education, the STEM education, and we have developed something called as CosmoKit, which goes with set of experiments about space where they build by themselves and, you know, learn the concepts through hands-on activities. So that's basically what CosmoKit looks like, and we have developed this particularly for students in the rural area, the government school students from you know, financially lower background, that type of students where it's impossible for them to learn something out of their books. This is something that we have developed, and we have tried giving this, and the results were amazing. We donated around 400 such CosmoKits for students in the slums of Chennai. In another 1 week, our team is also visiting Mumbai, the slums of Mumbai, and all this is supported by the corporate. So I would also keep the platform open for all of you. If you would like to support a student learning, I request all of you to support us. It costs one box like this with all the items, and our team going and teaching costs 999 rupees. This is not something for them to just learn and keep it aside, but this, whatever they're going to learn, is the beginning for them to start knowing more about space and the world and the universe. And in fact, at the end of the day, it's about the science, it's about thinking scientifically, it's about doing something different, just like what Sir said. You gotta be one step ahead. This is exactly what we are trying to do. So we request all of you to support us in any possible way for this by your donations, if you all can. Then apart from that, you also heard from Mahesh, we've been working on several things as our for-profit also, and we do have a lot of courses developed for students, which is pretty much like a very structured course, I can say, which is not just about one topic. You all know how SSCRD has been working on, and Genic Space is also trying to follow the same thing. Our focus is not just one topic, it's pretty much having a hands-on knowledge and on all the space domains, I can say. So this is how the courses are prepared from grade 3 to 12, like they're really awesome. If you would like to join and learn more, I think this is something that you can look for from Genex Space. So being said about both of them, for college students we also have something that's coming up, CanSat workshop. So if you all are interested, you can also go ahead and register or also share it across your friends. These are few updates from our end, and sir also said the James Webb Space Telescope picture. This is one of the picture where kind of explained some of the galaxies that we had never seen and the way they are oriented for what reasons. And these reasons were literally given hundreds of years back with just mathematical proofs, and now we are able to see. That's what science is all about. Today you start working on it, the results might be visible like after a long time. So it's important for us to start the work, for all of us to start the work today, so that the future generations might get that experience. So just wanted to end with that, and in case if you have any space related books, you are also requested to donate those books to us, or you can also courier it to our office address. I think I'm done with that, but I also wanted to thank Dr. Kumar sir for joining us. When sir said, Nikita, I want to come to India, I want to interact with students, I was very happy because there are very few people who want to come back or talk to students, interact with students, though they're like doing a lot of things, they're busy. One among them was again Dr. Kumar sir. As he mentioned, his colleague is again, his name is Gabe, he was here. I see these people are very dynamic, and they are not someone who just want to sit and like just keep the knowledge with them, but they are someone who want to like give. In India or anywhere across, giving something without expecting is something always considered as something very bigger, Shrestha, we call that as. They have been giving the knowledge as that, for everyone, just take it. And it is so important today because you don't get that easily. Trust me, you do not get that easily. And at this age, you are doing all this. And I have no other words but other than like thanking you and wishing you good health for a longer and longer period, and so that you keep inspiring more and more students. Thank you very much, and I would also like to thank everyone who are here, who joined as well as virtually for signing up this, and anyone who's going to watch this video in the future. And to my team, thank you so much for making this possible. Thank you very much.
Thank you so much, Nikita. If someone wants a copy of Sir's book with Sir's hand, they are very welcome to that. It will be around 320 rupees and $4. So whoever's want that book,
The printing charges, and that will go to the kids that I am supporting.